All right, my next section is going to be on buffers. If you're in the Brown LeMay text, this is chapter 17.2, section 17.2. What is a buffer? A buffer is a solution of weak conjugate acid base pair that resists drastic changes, and these pHs are called buffers. These solutions contain relatively high concentrations, 10 to the negative third or more, of both the acid and the base. Their concentrations are approximately equal. Okay. Ways to make a buffer. Number one, you can mix a weak acid and a salt of its conjugate base, or the weak base and a salt of its conjugate acid. The second way you can make a buffer is by a reaction. If you add a strong acid and you neutralize its weak base, okay, that will produce, at the end of the reaction, the weak base and its conjugate. Okay, I'm sorry, you'll be left with the weak acid, okay, and its conjugate. The other way, you could actually add a strong base to a weak acid, and that will produce the conjugate of the weak base. Essentially, in a buffer, you don't get any high concentrations of strong acid or strong base, so the pH doesn't go to either extreme. It keeps the pH from changing. That's what a buffer does. It keeps the pH from changing drastically. How a buffer works. If I'm in a buffer solution, just trying to get this thing. Okay. Let's lose that. Okay. If I have a buffer solution, this would be an acid buffer. Okay, I could start with HF, which is a weak acid. Now, if I asked you what's the conjugate of that, the conjugate base, which will also be weak, the conjugate of an acid, all you really have to do is take away the H. So it's fluoride. Weak acid, conjugate base. If you have that in appreciable quantities, you have a buffer. Now, this is looking at, here's my fluoride, here's my HF. If I take this system and I add an acid to it, the H is going to react with the fluoride to make HF. So after your addition of HF, your HF is increasing and your fluoride's decreasing. The ratio is changing, but it's not really changing your pH. It's buffering the amount of strong acid. That's the essence of a buffer. Okay? So I've done that by adding a small amount of acid, okay, and to the component of the buffer. In this case, it would have been a weak acid. It would have been a weak base that I added the acid to. Now, on the other aspect of that, on the other end, if I add a strong base, so this would be strong base addition. Sorry, this doesn't look too great. This side would have been strong acid addition. Okay. If I add a strong base to the system, it's not. It has a choice. You know, you have a base and an acid. Your base is going to react with the acid on this side of the world. So here's me adding the hydroxide, the strong base. It's going to react with the weak acid. This is not an equilibrium. This is a reaction, so you have a single arrow, not a double arrow. Okay, you have water as a product. And what it does is it increases the amount of conjugate base, the fluoride, and it decreases your amount of HF. Okay, and so effectively, what do buffers do? Buffers resist changes to pH. How do they do it? They do it by absorbing the strong acid by reacting with the weak base, or they absorb strong base additions by reacting with the weak acid. And that's what a buffer does. Okay, let's see, I'm not going to do that yet. But that is what a buffer is. I'm going to give you some examples of buffer systems. Let's try that. me see if I can get a new slide up. Okay. Buffer systems. Okay. If you had H2CO3, which is a weak acid, to create a buffer, you would add the conjugate base of the carbonic acid, so hydrogen carbonate, and that would be an acid buffer. Okay, if you had, we just said the conjugate's always going to be removing an H. The conjugate of a weak acid is, after it's acted as an acid, it's donated its hydrogen. So other buffer systems. If you had the HCO3, we're going to have that act as a weak acid now. It would donate the H, so you'd have carbonate. And again, that would be an acid buffer. Okay. If I had a base, an H3, so I have a weak base. If I add an H plus to that, that's going to make the conjugate acid, and that'll be ammonium. Now, if you see a system like this, it's going to be NH3 and NH4Cl. You're always going to need a counterion to your ion, and in this case, the chloride is a spectator, so you just want to ignore the chloride. If you had this system, you could have like sodium bicarbonate, baking soda, and sodium carbonate, which would be soda wash. In this case, you want to ignore the sodium because the sodium is only a spectator ion and it's not involved in the equilibrium. So when you get used to seeing buffers, you have to learn to disregard your spectator ions. Okay. Other buffer systems, if I had carbonic acid with sodium hydroxide, well, this is a strong base, and that would not be a buffer. Not a buffer. Well, if they were just in system, I gotta say, they would react. If I had something like hydrofluoric acid and I mixed it with HCl, because that's a strong acid, not a buffer. This kind of was a bad example because the hydroxide would actually react with that. So let me take that a step further. Okay. If I actually had carbonic acid, which is a weak acid, and I reacted that with sodium hydroxide, a strong base, I would get first the reaction. So I get carbonic acid reacting with hydroxide. I'm going to ignore the sodium because it's a spectator. So this is a one-way arrow. It would produce HCO3 and water, neutralizing it, okay? So in this case, at the end of the reaction, after, the hydroxide would go down to 0, and I would have H2CO3 and its conjugate, HCO3. So by a reaction, this would produce a buffer. And that's why it was a bad example. So anyway, your buffer, two types. Always a weak acid and it has to be its conjugate base. So example, hydrofluoric acid, conjugate base, fluoride, okay? And if you had a base buffer, most common weak base would be ammonia, and its conjugate acid, ammonium, and that would just be recognizing buffers. I could, besides just putting these two in, I could create it by adding ammonia plus hydrochloric acid, a strong acid. So if I had a reaction here, take ammonia, react H plus, the chloride spectating, single arrow, it produces NH4 plus, that's it, okay. At the end of this reaction, if I did a BCA table, you wouldn't have any H plus, you would just have NH3 and ammonia, and that would be a basic buffer. All right, we'll do more on buffers when we do Henderson-Hasselbalch equation.